Hey chemistry, so I'm going to talk to you about covalent bonds and how to draw them, and hopefully we'll be feeling good about them after this. So a covalent bond is going to be sharing electrons, because if you think about it this way, they're both negative, they both have a high number of electrons, and so therefore they really don't want to lose any, they'd rather gain some. And if you've ever had a sibling or somebody in your life, you probably had to share with them because neither one of you wanted to lose and you wanted to gain, right? You have a toy and you didn't want to give up the toy, they didn't want to give up the toy, so you ended up having to share the toy. And so whenever both things want something, they're gonna have to learn how to share. It's hard to share sometimes, but covalent molecules do it really well, and so that's what they're going to do, is they're going to share electrons. And so just like kids share toys, sharing electrons, and so think about the toy metaphor because we're going to use that a little bit. Now then, how we're going to represent sharing. In ionic compounds, we represented transfer with an arrow, and we're going to represent sharing with lines. Okay, and so we call these bonds, and so we could either have a single bond, a double bond, or a triple bond. Those are our only options. And so each line represents 2 electrons. And so the single bond, it has 1 line and it's going to represent 2. If I have a double bond, so I have 2 lines, then I'm going to be sharing 4 electrons. And then if I have 3, then I have 6 electrons. Okay, so hopefully that's making sense. Each line represents 2. So now we're going to go through the steps now that we kind of know what's going on. So right up here I have carbon monoxide, and it is a covalent bond, and we can always double check that. So your first step should always be to double check that you know which bond you're talking about. How do you double check it? You just make sure that they're both nonmetals. Carbon's a nonmetal, oxygen's a nonmetal. We're good to go. Step 2 is to add up all of their valence electrons. We care how many they have. So their electrons are what they're going to be sharing, and so we need to see how many toys there are in the house to share. We need to see how many electrons there are in the bonds to possibly share. And so first, carbon has 4 valence electrons, and oxygen has 6 valence electrons. So I'm going to add those together, and that is a total of 10 valence electrons. So I think about it like 10 toys. So I'm going to put it in a bucket. So we have a little toy bucket or an electron bucket. And in that bucket, whenever you have kids at a house or you're sharing with your sibling, you play with all your toys, right? And so we're going to use up all the toys. There's not some toys that just magically disappear, but we also can't come up with new toys out of thin air. So we're going to use exact numbers. So we're going to use exactly 10 electrons and no more than 10 electrons, no less than 10 electrons. Okay, and so as we use them, some of them are going to be shared. Are all of them going to be shared? No, they're never all going to be shared. Just like at home, you maybe have some special toys and things that are yours that you get to keep and you don't have to share. Same things with these guys. Some of them have some special toys that they don't have to share, but we do have to share some things, right? So, step 1, determine its covalent, check. Step 2, add up all of our valence electrons, check. Step 3, we're going to start to draw. And so we know that they're in a bond, so they have to be bonded, which means they have to be sharing at least 2, because we have to have at least a single bond. So there we have at least a single bond. So remember, that line represents 2, so they're sharing 2 toys right now. So that's your next step, is to connect them with a single bond. Now then, we've used up 2 toys out of our 10 toys, or 2 electrons out of our 10 electrons, and we have 8 left to use. What does everybody want to be stable? What are they trying to be like? They're trying to be like the noble gases. They all want 8 valence electrons. So we're going to give them 8 to make them stable. But remember, we can only use up 10. So I already have 2. So I'm going to say 4, 6, 8. And carbon has an octet. And I've used up 8 total electrons, or 8 toys. 2, 4, 6, 8, because remember that line represents 2. So I'm going to go ahead and start to give oxygen some, and now that's 10. So now I've used up my bucket. I can't put any more electrons on. If you're a sibling and you only have 2 toys to play with and you're sharing 2 toys, and your sibling has 6, that's not fair, and your parent's gonna make them share. And so carbon is gonna be a nice sibling and share its toys to make everything equal, because we always want everything to be equal, right? Her ice cream, she got more scoops than I did. And it's like, no, she didn't. And so we're gonna make everything as equal as we can. So not always will every molecule be equal, but we're gonna try. And so carbon's gonna be a nice sibling, and instead of keeping these 2 toys, these 2 electrons to itself, it's going to share them in the middle. So we didn't add any electrons, we just moved it from being over in carbon's pile to being in the middle to share. We still have 2, 4, 6, 8, 10 electrons on here. Carbon still has an octet, 2, 4, 6, 8. Oxygen doesn't have an octet yet, but it's closer. It has 2, 4, 6. Okay, because remember, the guys in the middle, everybody's sharing, so they both get them. Because when you share something, it's not yours and it's not the other person's, it's both of y'all's. If I'm sharing a pizza with you, we both get to eat the pizza. It's both of our pizza. It's not just mine, it's not just yours. So carbon is gonna have to be a little nicer and share one more set of toys. So now I've used up 10. There's 6 in the middle because I have 3 lines, remember? 6, okay? And then each one has 2 to themselves. So it's a total of 10, and everybody has an octet. And so that's how you're gonna do covalent bonds. So we're gonna do one more example. We have over here carbon dioxide. So step 1, make sure that it's a covalent bond, both nonmetals. Step 2, add up your valence electrons. So we have 4, and then we have 6, but I have 2 oxygens, so I need to add 6 twice, 1 for each oxygen, for a total of 16 in my bucket to share. Now I need to connect them with a line because they're all bonded together. Now then, if you ever have somebody who is all alone, they're going to be what's called your central atom. They're going to be the one that's in the middle. So I put carbon in the middle because I only have 1 of it and I have 2 of oxygens. So it's being sandwiched in the middle. This rule will be true for everything that we do in this class. So now then, I've used up 2, 4 already out of my bucket. So my next step is to start giving octets. Give your outside guys octets first, save the inside guy for last. So I'm gonna say 2, 4, 6. So now oxygen has an octet, that's 8 total, and I've used up 10 total dots. So now I'm gonna come over here, I have 6 more dots left to use up. I use up all 6 dots, so now I've used up 16 total electrons, 16 total toys, 2, 4, 6, 8, 10, 12, 14, 16. Oxygen has an octet, but carbon does not. So we need to share, and we want to be fair about our sharing. So oxygen is going to share 1 set. That doesn't give carbon an octet though, so this oxygen is also going to share. So that way there's equal sharing, because it's not fair if this oxygen has to share 3 sets of toys. Well, this guy only had to share 1 set of toys. That's not fair. So instead they both share 2. And so then we've used up 16, 2, 4, 6, 8, 10, 12, 14, 16, and everybody has an octet. This oxygen does 2, 4, 6, 8. Carbon does 2, 4, 6, 8. And oxygen does 2, 4, 6, 8. Okay, so that's how we do covalent bonds. Hopefully that's making a little bit of sense to you. It's 2 examples. We can do more in class, but at least you got something.